Hello everyone, section 10.7, circles in the coordinate plane. Example 1, write the standard equation for each circle. So the center of this circle in part A, right here, is at -5, 4. We plug that into the standard equation for a circle. We get x plus 5 squared plus y minus 4 squared equals, the radius is 4. 4 squared is 16. Part B, a circle with the center at the origin, so x is 0, y is 0, and the radius is 3.5. So x plus 0 squared is just x squared, plus y plus 0 squared is just y squared, equals, and 3.5 squared, I just checked on my calculator a second ago, is 12.25. That's example 1. Example 2. The point 4, 1 is on the circle. The center is 1, 4. Write the standard equation for the circle. So we can start off with knowing that we have x minus 1 squared plus y minus 4 squared equals r squared. We're going to have to find out what r is. Now, to find out what r, we want to know what's the distance from this point to this point. The center to any point on the circle is always going to be equal to r. There's a couple different ways we could do that. One, we could plot it and see if we are able to count the points. In this problem, we are not. We can use the distance formula between these 2 points. Using the distance formula, though, is the equation of a circle. There's no difference between the distance formula, the equation of a circle, and the Pythagorean theorem. They're all exactly the same. So I'm just going to plug in 4, 1 into my x and my y here. 4 minus 1 squared plus 1 minus 4 squared equals r squared. 3 squared is 9 plus 1 minus 4 is -3 squared, 9 again, equals r squared. So r squared is equal to 18. The question is not asking me what the radius is. I need to know what r squared is. Right? The radius is 3 square root 2, but I want to know what r squared is so I can complete my equation. X minus 1 squared plus y minus 4 squared equals 18. And there's the answer to example 2. Example 3 is leading us down the road of a process called completing the square. It's something that you're going to need to know when you take Algebra 2 next year. You're going to be doing it a lot. So this is kind of a preview of what's going on. Now, when you do it in Algebra 2, it's going to seem a lot more difficult than what is happening here. Okay, so we are given this equation, x squared plus 4x plus y squared minus 8y equals 16. We want to turn this equation into a standard form equation. So right now, it doesn't look anything like this. It doesn't look like we've got an x minus an h squared, a y minus a k squared, or an r squared. We can't read. We don't know that the r is 4. Probably isn't. So this is not r squared. We need to be able to turn this into this. How do we do that? So we start off by filling in these blank spaces here. Okay, that's the suggestion. And the suggestion is we fill them in so that when we fill in a number here, x squared plus 4x plus blank is going to factor into something that looks like this. Okay, so it's going to factor into something that's what we call a perfect squares trinomial. So what would we put here that's going to make this a perfect squares trinomial? And again, this is x squared plus 4x. That came from the original equation. What are we going to put here? Y squared minus 8y, y squared minus 8y. That's going to make this trinomial a perfect squares trinomial, so that when it factors perfectly into a y minus something squared. Okay, so to figure out what we put in there, we can do some trial and error. Okay, and that's really what they want you to do in this particular problem because you don't know the process. But I'm going to tell you the hint. We're going to take this number here. We're going to divide it by 2, and then we're going to square it. So when we take 4 and we divide it by 2, we get 2. And when we square that number, we get 4. X squared plus 4x plus 4. That's what goes into the blank. Plus y squared minus 8y plus, again, take the negative 8, divide it by 2, we get 4. Square that 4 and we get 16, and that's what's going into this blank. Not negative 16, but positive 16. It's always a positive number that goes here. Equals 16 plus blank plus blank. Now, I've just added a 4 and a 16 to the left-hand side of an equation. That unbalances the equation. I'm adding 20 to the left-hand side. I need to add a 4 and a 16 to the right-hand side of the equation to keep the equation balanced. The left-hand side, now we've designed this on purpose so that it will factor, always factors to a binomial squared. What's that binomial? X plus 2. This one's always going to factor into a binomial squared. Again, we designed it that way. Y minus 4 equals 32 plus 4, 36. Okay. Question's asking find the center and the radius. So the center is at negative 2, 4. And the radius is equal to 6. That is example 3. Example 4, we're given this equation here. And again, this equation is not in our standard form. And we're asked to graph it. We don't know what the center is. We don't know what the radius is. To graph this, we're going to need to complete the square that we just did in example 3. So we're going to follow the same process. So first we want to regroup these so that we have x squared minus 2x plus blank plus y squared plus 6y plus blank equals 6 plus blank plus blank. I moved the 6 from the left to the right. What am I putting into the blanks? Negative 2 divided by 2 is 1 squared, 1. 6 divided by 2 is 3 squared is 9. Left-hand side becomes x minus 1 squared plus y plus 3 squared equals 16. So I have the center is at 1, negative 3, and the radius is 4. Okay, so 1, negative 3 is our center. And now we're going to go up 4, to left 4, to the right 4, and down 4. So up 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And I'm going to, actually, I'm not going to try and freehand this. So let me go grab a compass. I grabbed my compass, and I'm going to the center of it at the center of the circle. Move this over so that I can see one of the points. And let's see if they connect. Slide a little bit because the base of the camera is getting in the way. Hopefully get things where they're supposed to be. And they did. And there's our answer to example 4. Okay, example 5. Prove or disprove that the point 3 comma square root 7. In example 5, prove or disprove that the point 3 comma square root 7 lies on the circle centered at the origin containing the point 1 comma 4. To do this problem, we first need to come up with the equation for the circle that has a center at the origin containing this point, and check to see by putting 3 comma square root 7 into that equation to see if it actually fits and works. So like we did in example 2, we're going to start off by writing x squared plus y squared equals r squared. I didn't write x minus h or y minus k because the origin is the center of the circle, so h and k are 0 and 0. We put in 1 comma 4 to find what the r squared is. 1 squared plus 4 squared equals r squared. 1 plus 16 equals r squared. And again, we are looking for r squared, and that equals 17. I don't need to know what r is. So I have the equation x squared plus y squared equals 17, and I want to see, does 3 comma square root 7 work in this equation? So 3 squared plus square root of 7 squared equals question mark above it 17. I want to know, does it actually equal? 9 plus 7 equals with a question mark 17. 16 does not equal 17. Okay, and we can actually tell one more thing. Because 16 is smaller than 17, we can tell that this point is inside of the circle, not outside of the circle. But we just wanted to know, does it lie on the circle? And the answer is no, not on the circle. Okay, example 6. Example 6 is a challenging problem. It's actually quite a bit going on here. And I've done this problem a few different ways. Let's see if we can boil it down to the easiest way that I have found to be able to do this problem. The epicenter of an earthquake is the point on the Earth's surface directly above the earthquake's origin. A seismograph can be used to determine the distance to the epicenter of an earthquake. Graphs are needed in 3 different places to locate the earthquake's epicenter. Use the seismograph readings from locations of X, Y, and Z to find the epicenter of an earthquake. Okay, so the epicenter is 10 miles away from point X, which is at -1 comma -3. The epicenter is 2 miles away from point Y, which is at 5 comma 3, and the epicenter is 5 miles away from the point Z, which is at 2 comma 9. So these 3 facts are giving us 3 equations of circles. The first one gives us the equation x minus 1 squared plus y, x plus 1 squared, y plus 3 squared equals 100. 10 squared. X minus 5 squared plus y minus 3 squared equals 4. X minus 2 squared plus y minus 9 squared equals 25. So here we have 3 equations for the 3 circles, and we want to know essentially where do these 3 circles all meet in one point. Okay, they have to, otherwise there wouldn't be an epicenter for the earthquake. Okay, so since we're describing one single earthquake, so one of the things that I tried was I tried graphing these 3 equations by hand and seeing where they intersected to see if there was an easy point that would be easy to find where they intersected. There is, but it didn't jump off the page at me right away. Okay. Then I thought about using algebra. And this is the way your Algebra 2 teacher is going to want you to do it next year, is to solve this complicated system of equations. Solve for one of the variables, plug it in until you are eventually able to get down to finding the single point that works for all three of these equations. Typically, there are 2 points where the two circles intersect. Not always. They might not intersect at all. They might be tangent. They might intersect at 1 point. But I believe these all intersect at 2 points each. And so it's solvable. It's not easy to solve, but it is solvable. Then I took a look at graphing it more carefully on graph paper. And I said, you know what? I've got some graphing software that I can use. And let me take a second to pull up Desmos, and I'll show you what I came up with. Try switching to Desmos. Hopefully this is still recording. You can see this. So what I've done is I plugged in the 3 equations that we came up with. The first one, the second one, and then the third one. And I do notice that they do meet at 1 point. And I don't want to hover over that point because Desmos is actually going to tell us what that point is. And I don't want you to know what that is yet. And you'll see why in a second, because when doing this, you probably won't have Desmos. So what I realized when I graphed the first equation, when I graphed it by hand, I plotted the point -1, -3. And then I plotted the point up from that 10 units up, which gave me this point here, -1, 7. And then I went 10 units to the right, which gave me a point over here, 10 units to the left, 10 units down. Okay, and I did the same thing when I went and I plotted the second equation, which was x minus 5, y minus 3 equals 4. And I applied the point 5, 3 here. And then I went up 5 spots, to the right 5 spots, to the left 5 spots, and down 5 spots. And I noticed, or at least I should have noticed when I did my quick sketch, that I'm hitting that first equation in 2 parts. And notice, if I go straight up, that's a point that I can count pretty quickly. If I go right to the right here 5 points, that's another point that I know the coordinates of, right? I know that the coordinates here have to be 7, 3, because I was at 5, 3, and I moved to the right 2 spaces because of the radius, and I get 7, 3, and I get 5, 5 if I go straight up. Okay, so what I could have done at that point, let me go back here. Okay, hopefully you guys can see this now. Again, when I went to the right and got 7, 3, and to the left and got 5, 5, I can test those in the first equation to see if either of them work. Now they both work, but let's test them anyways. We know that from the graph, from Desmos, but we didn't know that when we started the problem. So we go 5 plus 1 squared plus y, testing the point 5, 5. 5 plus 3 squared equals, with a question mark, 100, because I need to know if they actually work. 6 squared is 36, plus 8 squared is 64, equals, with a question mark, 100. 100 does equal 100. So 5, 5 is on both of these circles. What about 7, 3? Let's try it. 7 plus 1 squared plus 3 plus 3 squared equals, with a question mark, 100. 8 squared, 64 again. 6 squared, 36 again, does equal 100. Both the points work, 5, 5 and 7, 3. What I don't know is, do either of them work in this equation? So I didn't even need to graph this one. Let's take a look. I'm going to show you 7, 3 first. 7 minus 2 squared plus 3 minus 9 squared equals, with a question mark, 25. 7 minus 2 is 5, squared is 25, plus 3 minus 9 squared is negative 6, squared is 36, equals, with a question mark, 25. 25 plus 36, 50, 61, does not equal 25. That point is not on the third circle, but is 5, 5. 5 minus 2 squared plus 5 minus 9 squared equals, with a question mark, 25. 3 squared is 9, plus 4 squared is 16, equals, with a question mark, 25. 25 does equal 25, check. So the point 5, 5 is the answer to all three of these equations, the only point that's on all three of the equations, making this the epicenter of the earthquake, which, when we look at Desmos, 5, 5 is the intersection of all three of these circles. Okay, example 7. Find the equation of the circle that has a given center and radius. X squared minus 0, or x minus 0 squared is just x squared, plus y minus 0 squared is y squared, equals 144, 12 squared. Part B, x minus 3 squared plus y minus 7 squared equals 2 squared, or 4. X plus 1 squared plus y minus 5 squared equals square root of 2 over 2 squared is going to be 2 over 4, or 1/2, 0.5. Part D, x minus f squared plus y minus g squared, g, equals s squared. Example 8 is asking us to go backwards. 2, 1, and r equals 5. 5, negative 7 equal, comma, r equals 11. Negative 6, negative 13, comma, r equals 9. And n, negative m, n, negative m, and square root of 17, r equals the square root of 17. That's part D. All right, example 9, a square with vertices 3, 3, 3, negative 3, negative 3, 3, and negative 3. Negative 3 are drawn and a circle is inscribed in the square. What is the equation of the circle? So 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Here's our square. Circle is drawn inside of this. Clearly it's centered at the origin. Has a radius of 3. So we have x squared plus y squared equals 9. Here's example 9. Example 10. A circle has a center 3, 4, passes through the point 2, 2. Find the radius and equation of the circle. So let's start off by finding the equation. X minus 3 squared plus y minus 4 squared equals r squared. To find what r is, we're going to use the point 2, 2. 2 minus 3 squared plus 2 minus 4 squared equals r squared. Negative 1 squared is 1 plus negative 2 squared is 4 equals r squared. So we have the equation x minus 3 squared plus y minus 4 squared equals 5. R squared equals 5. Therefore, r is equal to square root of 5. Example 11. Communications. When you make a call on a cellular phone, a tower receives the call. In the diagram, the centers of circles O and A are the locations of cell phone towers. So here's circle O, here's circle A. The equation, x minus 16 plus y minus 10 equals 100, models the position of tower range, the position and the range of tower A. So the position is at 16, 10. It's got a radius of 10, we'll assume miles. Part B, a new tower is to be built at point B, here, with a range indicated on the graph. So the range is going to go from 4 out to 10, these are by 2s, so 10, 12, 4, 14. So it's going to have a range of 10 as well, radius of 10 as well. Write the equation, describe the position and range of tower A. So the position of tower A is 16, 10, the radius of 10. And again, we're not told if these are in miles, so we're just going to leave it as r equals 10. Part B, we want to come up with the equation for this particular circle. So this one's going to be x minus 4 squared plus y minus 20 squared equals, the radius we calculated was 10, or counted was 10, so equals 100. And part C, write an equation that describes the position and range of tower O. So tower O is centered at the origin and has a radius of 2, 4, 6, 8, 10, 12. So we get x squared plus y squared equals 12 squared, or 144. Example 12. For x minus h squared plus y minus k squared equals r squared, we want to show that y is equal to this expression, or it's equal to this expression, which is exactly the same. The difference is we have a positive here and a negative here in front of our radicals. Other than that, they're exactly the same. So we want to show that by solving this original equation here for y. So let's start with the original equation. I'm going to rewrite the original equation, x minus h squared plus y minus k squared equals r squared. I'm going to subtract x minus h squared from both sides. Y minus k squared equals r squared minus x minus h squared. Very similar to what we've got going on here. And now we have to take the square root. Our goal is to get y alone, so to get rid of the squaring, we square root both sides. Y minus k equals. And here's where your algebra skills are going to come in. Whenever you put in the square root, you must add in plus and a minus. Plus or minus square root r squared minus x minus h squared. Add k to both sides. Y equals k plus or minus square root r squared minus x minus h squared, all inside that square root. And this expression is this one and this one all in one. I reordered it to put the k out in front, but it's exactly the same. That's example 12. Example 13. Nautical distance. The radius of the Earth's equator is about 3,960 miles. Write an equation of the equator with the center of the Earth as the origin. So x squared plus y squared equals 3,960 squared. Find the length of 1 degree of arc on the equator to the nearest tenth of a mile. Find the length of 1 degree of arc on the equator to the nearest tenth of a mile. To do that, we need to know what the circumference is at the equator, the circumference of the equator, and then just divide that by 360 degrees to find out what 1 degree is. So circumference equals 2 pi r. Circumference equals 2 times pi times 3960, which is approximately 2 times pi times 3960, about 24,881.4138 miles. And then we're going to take that and divide that by 360. And I get approximately 69.1 miles as 1 degree. A 1 degree arc along the equator is 60 nautical miles long. So how many miles are in a nautical mile? So we take our 69.1, divide that by 60. And we get approximately 1.15 or 1.2 miles in a nautical mile, approximately. All right, history, part D. Columbus planned his trip to the east going west. He thought each degree was 45 miles long. He estimated the trip would be 21 days. We're going to use our estimate of 69.1 miles and figure out how many days that would be. We're going to set up a proportion here. If 45 miles is about 21 days, then 69.1 miles is approximately X days. Cross product property, 45x equals 21 times 69.1. X equals 21 times 69.1 divided by 45, or approximately 32 days is what the trip should have taken. All right, example 14. Find the equation of a circle described. So we have the center is at 5, 5, and it's tangent to both axes. So 5, 5, 5, 1, 2, 3, 4, 5, and it's tangent to the x and the y axes. Okay, so it's got a radius of 5. X minus 5 squared plus y minus 5 squared equals 25. Circle has a center P, comma Q, and is tangent to just the x-axis. So that means it's got a radius of Q. It's Q. So if this is P, comma Q, and this here is Q length. Okay, so we get x minus P squared plus y minus Q squared equals Q squared. All right, example 15. 2 points on the circle, x minus 2 squared plus y minus 4 squared equals 25. Both have y coordinate of 7. What are the x coordinates for the 2 points? Okay, so we're going to plug in 7 into the y and figure out what x is. We're going to get 2 different answers here. X minus 2 squared plus 7 minus 4 squared equals 25. X minus 2 squared plus 7 minus 4 is 3. 3 squared is 9. It's 25. Subtract 9 from both sides. X minus 2 squared equals 25 minus 9, 16. Square root both sides because we want to get x alone. And here's where we get our 2 answers. I put that square root into the equation. We have to put in plus or minus. X minus 2 equals plus or minus square root of 16, which is 4. Add 2 to both sides. X equals 2 plus or minus 4. X equals 6 or negative 2, giving us 6, 7 and negative 2, 7 as the 2 points that are on this circle that have y coordinates of 7. Example 16. Draw the first circles obtained by using all combinations of these signs. So we have x plus 4 squared plus y plus 4 squared equals 16, x minus 4 squared plus y plus 4 squared equals 16, x plus 4 squared plus y minus 4 squared equals 16, and x minus 4 squared plus y minus 4 squared equals 16. All these different combinations. Basically what we get are the coordinates 4, 4, negative 4, 4, negative 4, negative 4, and 4, negative 4. And all 4 of these circles have radii of 4. And I'm going to pull out that compass again. See what we get. Hard to see. Get the crosshairs. I think. Slide things back up again. Just missed. There's one circle. Second circle, I'll slide this up so you can see it in a second. If I have it up too far, then the compass hits the base of the camera. And I go and draw these circles. Third circle, and then the last one. That's on the center. there are our 4 circles. Part B, write an equation of the circle that surrounds the 4 given circles and is tangent to them in simplest radical forms. Now we want a circle centered at the origin that's going to touch all 4 of these circles at one point each. And again, slide back here a little bit. Just missing, just by a hair. I think you get the idea. What we're looking for. And what do we notice when we do that? What do we get for a radius? We get x squared plus y squared equals 100. An equation of a circle that surrounds, that's tangent to each one of them. And you can test that to see if these points end up on these circles. Write an equation of another circle that is tangent to each of the 4 circles in simplest radical form. There's another one. Where is it? Again, centered at the origin, but this time it's inside. And I'm not sure if I can make this. I think I might. It's going to be tight. It's going to be tight. Yeah, it's too big. Too big. It's not tangent. So inside this time. This one is significantly harder than the last one. Really, I should have done this on the last one too, but I didn't for part B because I noticed that it was going through 10, 10, negative 10, negative 10. But really, it's going through these 2 lines here. This line here, which is the line y equals x, and this line here, which is the line y equals negative x. So really, they're tangent at these points where these circles intersect those lines. But this circle intersects the line y equals x at 2 points. It also intersects here. Y equals negative into x equals this one here, and this one here. So what I care about, let's take a look at this circle here, which is x squared plus 4 squared plus y plus, oops, not x squared plus 4, just x plus 4. Y plus 4 squared equals 16. I want to know where that circle intersects the equation y equals x. So I'm going to substitute x in for the y. X plus 4 squared plus x plus 4 squared equals 16. 2x plus 4 squared equals 16. Divide both sides by 2. X plus 4 squared equals 8. Square root. X plus 4 equals plus or minus 2 square root 2. Subtract 4. X equals 4 plus or minus negative 4 plus or minus 2 square root 2. Okay. So if I do sorry, that's this point. I'm doing this one down here. I grabbed the wrong equation. Doing this one, and we found this point right here. So negative 4 plus 2 square root 2 is going to come out here, here. And negative 4 minus 2 square root 2 is going to come out here. And if I find the distance from this point to the center, that's going to be the radius of the circle, which was 10. And if I find the distance from this point to the center, that's going to be the radius of the circle, and that's what we're going to have to use. So we go like this. Again, we have the center 0, 0. I'll slide up. X squared plus y squared equals r squared. X is, because it's at 0, 0, so it's x squared plus y squared. X is at negative 4 minus 2 square root 2. Negative 4 minus 2 square root 2 squared plus x and y are the same coordinates. Negative 4 minus 2 square root 2 squared plus both of these. The minus was this one. The plus is this, the middle one. Equals r squared. So r squared is equal to 2 negative 4 plus 2 square root 2 squared. And sure, if we could probably simplify this some more, let's try it. This is going to be 16. Negative 8 square root 2 times 2 is minus 16 square root 2 plus 8. 16 plus 8 is 24. Minus 16 square root 2. So 48 minus 32 square root 2 is equal to r squared. So x squared plus y squared equals 48 minus 32 square root 2. For our final answer to part C. Okay, thank you very much. Bye.